Alright, welcome. This is the Ready Set Go 7.4 homework solutions. Alright, here you have the ready part. Alright, it says that the corresponding given the figure in each sketch with congruent angles, side mark, first list the part of the image that corresponds, then determine if reflection occurs as part of the sequence of transformations that was used to create the new image. Here, I have the original image here. I rotate the right triangle 90 degrees clockwise. Okay, that's why the R goes on top. And the S was right here. It goes to the bottom because of the 90 degrees clockwise rotation. Then I reflect it over the vertical line of RS. That's why it flipped. The R was on the right hand side. Now it's on the left hand side. Couple of things that I got. I got angle C is equal to angle R. That's what that curve is. Angle line AC is equal to line TR. And CB is equal to RS. Okay. Then this is true already, but I can infer. Okay. I can infer this. I could also infer that AB has to be congruent to TS by CPCT. Okay? How do I know that? Because this is side angle side, so these two are congruent by side angle side. If the triangles are congruent, right, congruent triangle, then the parts are congruent. That's how I got AB is equal to TS. Okay? That's how I can prove that. Yes, there was a reflection. The reflection occurred here. From reflection over the vertical line of line RS. Next, I have this image, and I got this image. I rotate this image 180 degrees. Alright. Okay. Angle F here is congruent to angle Y. Angle G is congruent to angle Z. Angle H is congruent to angle W. Angle E is congruent to angle X. Line EF is congruent to XY. That's the first hash mark. And I don't think they will allow me to do these two. Okay. You could infer it, but they don't want you to. All I know is it's side angle side, but it's not a triangle, but I know it's valid. But the only two parts that you know is this side and this side. Okay? That's the first hash mark and the second hash mark. Notice there was no reflection. There was only an 180 degree rotation. Alright. Next one. Here's the set part. The set part. You are going to explain whether or not the triangles are congruent, similar, or neither based on the mark that indicates the congruencies. Remember, congruent, we have our four. Angle side, angle side, side, angle side, and side angle side. Don't quote me on that. I know it's four of them. Okay? I don't know them off my head. I know the first one, side. That is a congruency. Next one, this is angle. That's not congruent. That's not part of R4. But we will say they are similar because, right, they have the same angle. Next, this is not congruent nor similar because it is what? Side angle. That's not part of R4. Next one, I would say this is congruent because this is side angle side angle side angle side. Next one, this is congruent by angle side angle side. Alright, next one, this is not congruent nor similar. This is what? Angle side angle side. Remember, there's no ASS. Alright, that is not part of our congruency triangles. Okay? Next one, using the given congruent statements to draw and label two triangles that have the proper corresponding parts congruent to each other. Triangle ABC is congruent to PQR. Okay, I just want you to notice something about this, okay? Notice this. Look at the way this is, alright? So so you can say right here, you can say that angle A, it's right here, has to be equal or congruent to what angle? Right here, P. Do you see that? You could also say, do the first one, right? Line, what's the first one? AB has to be congruent to, pick the first two as well, PQ. Right? Do you see how this is written in a way that all the angles match up with its corresponding part and the sides also match up? I did it right here as well. Okay? That's how I got this image. Right? I could do the rest for you if you like. I think the second one should be... Okay. The second one is B. B is the second one, so it has to match up with Q. C, angle C has to match up with angle R. Right? And there should be 3 lines. Okay? The first one is AB equals to PQ. Right? That's the first two. Then we could take the second two, BC. BC is equal to QR. And I could do first and last, which is AC, is equal to PR. Alright, looking at the image, that is correct. Alright? Likewise, okay, you could do the same one here if you want, but I'm not going to do it. You could just use the image there to help you. Okay? There you go. Here's the go part. The go part is very straightforward. This is just solving the system. You're just applying your inverse property, okay? I wrote all the steps down here if you would like to see it. Number 1, you have this. My first step is to get rid of the fraction, so I multiply 5 to both sides. I get this, right? I have the negative 4. That's why you're going to add 4 to both sides. Then I get the 3 in front of the t. So you're going to divide the 3 to both sides. I get t equals to 29 over 3. You cannot simplify that. Okay. Next one. Here's my original equation. You see the negative 3t and the 4t? You can combine the variables on the right hand side of the equation. Get you 1t. Right? There was a t on the left hand side. So you're going to add t to both sides. You see the constant of 12. Right? Get that away by subtracting 12 to both sides. 2 is still in front of the t, so you're going to divide 2 to both sides. Gets you t equals to negative 1. 13, p equals to 5t. Subtract d. You're still trying to solve for t. This is the literal equation. Alright? So you want to get rid of the negative d first by adding d to both sides. Then the 5 is still in front of the t, so you're going to divide by t to both sides. 14, again, there is a t on both sides, so you're going to add t to both sides to get rid of that. Okay, there's this plus w that we have to deal with, so the opposite or the inverse of add w would be subtract w. Do that to both sides. 14 is still in front of the t, so you are going to divide 14 to both sides. You get t is equal to xy minus w divided by 14. Last one, use the given sequence of numbers to write a recursive rule for the nth value of the sequence. Remember there are 2 types of sequences, arithmetic and geometric. Here's the first one, 5, 15, 45. That is growing largely. We call that geometric. Geometric has a common ratio. Alright, the common ratio here is 3. That's how you get 3 right there. First term is 5. Okay, here is the recursive. The previous term is going to be multiplied by 3. That's how you get the next term. 5, what's the previous term? 5 times 3 is 15. How do you get the next one? The previous term was 15, times that by 3. Next one, 1 half, 0, negative 1 half, negative 1. Okay, this is arithmetic. It's going down steadily. The first term is 1 half. The recursive, rule would be the previous term, subtract 1/2. Why is it subtracting 1/2? It's going down by 1/2 each time. Next, 17. 3, -6, 12, and -4. It's growing weirdly. It's basically like oscillating. We would say this is a geometric sequence. The first term is 3. Notice, to get the next term, you're multiplying by -2. And negative times the negative finally gets you a positive. This is why it's oscillating between positives and negatives. So it's the previous term, which is f parentheses n minus 1 times -2. -2 is the geometric ratio, common ratio for the geometric sequence. Lastly, 16, 1/2, 1/4, 1/8. That is an arithmetic sequence, right? No, this is geometric, right? It's going 1/2, 1/4, 1/8. The first term is 1/2. To get the next term, the recursive would be the previous term times 1/2. Good? Alright, there you go. That was a quick explanation on all the homework solutions for your 7.4.